Hello, Dr. Spalding here. In this lesson, we're going to convert the equation of a vertical ellipse from general form to standard form and find the center, vertices, covertices, and foci. And once we get the equation into standard form, we'll be able to see why it is going to be a vertical ellipse. So whenever we're in standard form for the equation of an ellipse, the equation will be set equal to 1. So I want to have my constant on the other side of the equation. So let's go ahead and get rid of minus 399 by adding 399 to both sides. Also, I'll use the commutative property of addition to put my x terms together and my y terms together. So I have 25x squared minus 250x plus 16y squared minus 192y equals 399. Now I want to complete the squared with the x's and the y's. When I complete the square, I want to have an x squared, not a 25x squared. So to get an x squared, I'm going to factor out 25. And I'll also factor out 25 from negative 250x. So that gives me a negative 10x. And at this stage, I'll go ahead and complete the square. I need b divided by 2 squared. B is the coefficient of the linear term. Our linear term is negative 10x. So the coefficient of the linear term is negative 10, so b equals negative 10. So we have b over 2 squared, so plus 10 over 2 squared. Oh, excuse me, negative 10 over 2 squared. I also want to complete the square for 16y squared minus 192y. Instead of a 16y squared, I want a y squared, so I need to factor out 16. I'll also factor out 16 from negative 192y. That gives me a negative 12y. And I'll complete the square by doing b over 2 squared. B is negative 12, so I'm going to add negative 12 over 2 squared. But I can't just add negative 10 over 2 squared and just add negative 12 over 2 squared because the equation is not balanced. So I need to balance the equation by making sure I add the same thing to both sides. Well, if we look, we didn't just add negative 10 over 2 squared. It's also being multiplied by 25, because a 25 would be distributed. So I'm going to add 25 times negative 10 over 2 squared to the right side. And similarly, I can't just add negative 12 over 2 squared. I have to keep it balanced. But it's not just negative 12 over 2 squared. That's being multiplied by 16. Because this 16 would be distributed to the negative 12 over 2 squared. So I'm going to add (16) times negative 12 over 2 squared to both sides. So on the left, we have 25 times negative 10 over 2 squared. And on the right, we have 25 times negative 10 over 2 squared. And on the left, we have 16 times negative 12 over 2 squared. And on the right, we have 16 times negative 12 over 2 squared. So the equation is balanced. All right, so let's go ahead and simplify step by step. Negative 10 divided by 2 is negative 5. Negative 12 divided by 2 is negative 6. Same thing here. Negative 10 divided by 2 is negative 5. And negative 12 divided by 2 is negative 6. The negative 5 squared is 25. Negative 6 squared is 36. Again, negative 5 squared is 25. And negative 6 squared is 36. Now here and here, I've created perfect square trinomials. So now I've completed the square, and I can factor x squared minus 10x plus 25 as the quantity x minus 5 squared. And I can factor y squared minus 12y plus 36 as the quantity y minus 6 squared. And on the right side, 25 times 25 is 625. And 16 times 36 is 576. And 399 plus 625 plus 576 equals 1,600. So we're looking good, except that in standard form we want our equation to be equal to 1, not 1,600. So to get this equation equal to 1, we're going to divide both sides of the equation by 1,600. So 25 times the quantity x minus 5 squared over 1,600 simplifies to x minus 5 squared over 64. And 16 times y minus 6 squared over 1,600 simplifies to the quantity y minus 6 squared over 100. And now that equals 1. And we've written the equation in standard form. But I'm going to write this equation a little differently. Six squared, I'm sorry, 64 is 8 squared. And 100 is 10 squared. Okay, so the larger denominator is going to be a squared. So the larger denominator is 100, the smaller denominator is 64. So the larger denominator is underneath the y squared term, so our a squared is going to be underneath the y squared term. So a squared equals 100. And then our smaller denominator, b squared, is underneath the x squared term, and this equals 1. And this is the formula for the standard form of a vertical ellipse, because a is always greater than b with ellipses, and a squared is in the denominator of the y squared term, which makes it a vertical ellipse. Alright, so we can see that we have a b squared and an 8 squared, so b equals 8. And we have an a squared and a 10 squared, so a equals 10. All right. Let's talk about the center. The center is going to be HK. So H comes after the minus with the x. So after the minus with the x is 5. So H equals 5. And K comes after the minus with the y. So after the minus with the y is 6. So K equals 6. So the center is 5, 6. Now let's talk about the vertices. The vertices for a vertical ellipse are going to be H, K plus A, and H, K minus A. Well, H is 5, K is 6, plus A is 10. So we get that one vertex is the point 5, 16. And the second vertex is H, which is 5, K, which is 6, minus A, which is 10. So we get that the second vertex is the point 5, negative 4. Now let's talk covertices. The covertices for a vertical ellipse are going to be H plus B, K, and H minus B, K. So H is 5, plus B is 8, and then K is 6. So one covertex is 13, 6. The other covertex is H, which is 5, minus B, which is 8, K, which is 6. So the other covertex is negative 3, 6. Now for the foci. The foci for a vertical ellipse are going to be H, K plus C, and H, K minus C. But we need to figure out what C equals. So we have the relationship for ellipses that C squared equals A squared minus B squared. Well, A squared was 100, and B squared was 64. So we have C squared equals 100 minus 64, which is 36. And we're already taking into account the positive and negative versions when we add and subtract C. So we'll just take the positive square root of C and say C equals the square root of 36, which is 6. So now we can come back here and find our foci. So one focus is H, which is 5, K, which is 6, plus C, which we found to be 6. So one focus is the point 5, 12. And the other focus is H, which is 5, K, which is 6, minus C, which is 6. So the other focus is 5, 0. And here is a graph of the ellipse. So you can see it is a vertical ellipse. The major axis is vertical. The minor axis is horizontal. You can see the two vertices, 5, 16, 5, negative 4, the co-vertices of negative 3, 6, and 13, 6, the center of 5, 6, and then the foci of 5, 12, and 5, 0.